Hello, good afternoon, student. My name is Hiral Raval. Today's date 16 January 2021. Standard 10th subject Science. Chapter number 12 Electricity. Topics in the chapter: Introductions, Current, Potential difference, Volt definitions, Voltmeter, symbols of some commonly used components in circuit, Ohm's law. Mathematical expression for Ohm's law. V versus I graph for Ohm's law. Resistance, Ohm, rheostat. Factors on which the resistance of a conductor depends. Then resistivity. Resistors in series. Total resultant overall effective resistance in series. Then voltage across each resistors. Resistors in parallel. Advantage of parallel combination over series combination. Then heating effect of electric circuit. Joule's law, heating effect of electric current. Filament of electric bulb is made up of tungsten, electric fuse and electric power. Introduction. Charge is a fundamental particle in an atom. It may be positive or negative. Like charges repel each other. Unlike charges attract each other. Coulomb, SI unit of charge. Coulomb charge is equal to charge present on approx 6 into 10 10 raised to 18 electrons. Okay, 0.6 into 10 raised to 18 electrons. Charge is on 1 electron. Negative charge, so 1 point. So charge is on an electron, negative charge 1.6 into 10 raised to minus 19 coulomb. So Q is equal to N into E, where Q is equal to charge total, then N is equal to number of electrons, E is equal to charge on one electron. Then current I is equal to the rate of flow of charges is called current. Current is equal to charge upon time. So I is equal to Q upon T. Here the circuit diagram, SI unit of current is equal to ampere A. So 1 ampere is equal to 1 coulomb into second inverse. 1 milliampere is equal to 10 raised to minus 3 ampere, and 1 microampere is equal to 10 raised to minus 6 ampere. Current is measured by ammeter. Its symbol is like this: ammeter plus minus. Ammeter has low resistance and always connected in series. Direction of current is taken opposite to flow of electrons, as electrons were not Electrons were not known at the time when the phenomenon of electricity was discovered first, and current was considered to be flow of positive charge. Here the potential difference V, work done to move a unit charge from one point to another. So V is equal to W upon Q. So 1 volt is equal to when 1 joule work is done in carrying 1 coulomb charge, then potential difference is called 1 volt. SI unit of potential difference is equal to volt. So 1 volt is equal to 1 joule second inverse. 1 volt is equal to when 1 joule work is done in carrying 1 coulomb charge, then potential difference is called 1 volt. So V is equal to W upon Q. Here the another definition is voltmeter. It is an instrument to measure the potential difference. It has high resistance and always connected in parallel. Symbol is this. Okay, V symbol is this. This is a symbol of voltmeter. Then cell is the simplest device to maintain potential difference. Current always flow from higher potential to lower potential. Symbols of some commonly used components in circuit. This is the components. ये जो है वो टेक्स्ट बुक्स में भी दिए हैं. This is the statements of Ohm's law. Then potential differences across the 2 points of a metallic conductor is directly proportional to the current passing through the circuit provided that temperature remains constant. Then mathematical expression for Ohm's law is equal to V proportional to I. So V is equal to IR. R is a constant called resistance for a given metal. V versus I graph for Ohm's law. This is the Ohm's law. Then resistance R. It is the property of a conductor to resist the flow of charges through it. Ohm. This is the symbol of Ohm. SI unit of resistance. 1 ohm is equal to 1 volt per 1 ampere. When potential difference is 1 volt and current through the circuit is 1 ampere, then resistance is 1 ohm. Then rheostat, variable resistance, is a component used to regulate current without changing the source of voltage. Here the factors on which the resistance of a conductor depends. Resistance of a uniform metallic conductor is first directly proportional to the length of conductor, second inversely proportional to the area of cross section, third directly proportional to the temperature, and fourth depends on nature of material. Then here the resistivity P. It is defined as the resistance offered by a cube of a material of a side 1 meter when current flows perpendicular to its opposite faces. Its SI unit is ohm into meter. Resistivity does not change with change in length or area or a cross section. But it changes with change in temperature. Range of resistivity of metals and alloys is 10 raised to minus 8 to 10 raised to minus 6 ohm into meter. Then resistivity of metal resistivity of insulator is 10 raised to 12 to 10 raised to 17 ohm into meter. हम ऐसे लिखते हैं 10 raised to 12 to 10 raised to 17. यहाँ गलती से ऐसा हो गया. ऊपर क्या था? मेटल में 10 raised to -8 to 10 raised to -6 ohm into meter. Alloys do not oxidize readily at high temperature, so they are commonly used in electrical heating devices. Copper and aluminum are used for electrical transmissions lines as they have low resistivity. Then resistors in series. When two or more resistors are connected end to end, the arrangement is called series. Here the combinations. Total resistance overall effective resistance in series. So Rs is equal to R1 plus R2 plus R3. Current through each resistor is same. Then equivalent resistance is larger than the largest individual resistance. So total voltage is equal to sum of voltage drop V is equal to V1 plus V2 plus V3. So voltage across each resistor, V1 is equal to IR1, V2 is equal to IR2, bracket में V1 plus V2 plus V3 is equal to V. So V3 is equal to IR3, V is equal to IR. So V is equal to IR1, IR2 plus IR3. Proportional to IR is equal to I common. So we get R1 plus R2 plus R3. I cancel हो जाएगा. So R is equal to R1 plus R2 plus R3. Then resistors of in parallel. पैरेलल सर्किट में ऐसा होता है. दिस इज द डायग्राम ऑफ पैरेलल सर्किट. Resistors in parallel, voltage across each resistor is same and equal to the applied voltage. Total current is equal to sum of currents through the individual resistors. I is equal to I1 plus I2 plus R3. So V upon R is equal to V upon R1 plus V upon R2 plus V upon R3. Then reciprocal. Reciprocal of equivalent resistance is equal to sum of reciprocals of individual resistances. So 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Equivalent resistance is less than the value of the smallest individual resistance in the combinations. So advantages of parallel combination over series combinations. In series circuit, when one component fails, the circuit is broken and none of the component works. Then second, different appliances have different requirement of current. This cannot be satisfied in series as current remains same. Third, the total resistance in a parallel circuit is decreased. Then heating effect of electric circuit. Heating effect of electric circuit. If an electric circuit is purely resistive, the source of energy continuously get dissipated entirely in form of heat. This is known as heating effect of electric current, as E is equal to P into T proportional to VIT, where E is equal to H. So H is equal to VIT. ओके VI तो क्या, VT तो क्या हो गया R. So V is equal to IR. तो we can write H is equal to I square RT. Here this is write to this manner. H is equal to I square RT. This is the equation. Then Joule's law of heating effect of electric current. It states that the heat produced in a resistor is directly proportional to square of current. So H is equal to I square. It is directly proportional to resistance for a given current. So H proportional to R. It is directly proportional to time for which current flows through the conductor. H proportional to T. So H is equal to I square RT. Heating effect is desirable in devices like electric heater, electric iron, electric bulb, and electric fuse. Heating effect is undesirable in devices like computers, computer monitors, CRT, TV, refrigerator, etc. In electric bulb, most of the power consumed by the filament appears a heat, and a small part of it is radiated form of light. Then filament of electric bulb is made up of tungsten because it does not oxide readily at a high temperature. It has a high melting point 3380 degrees centigrade. The bulbs are filled with chemically negative gases like nitrogen and argon to prolong the life of filament. Electric fuse. It is a safety device that protects our electric appliances in case of short circuit for overloading. Fuse is made up of pure tin or alloy of copper and tin. Fuse is always connected in series with a live wire, and fuse has low melting point. Current capacity of fuse is slightly lighter than that of the अप्लायंसेस, ओके, उसकी जो इफ़ेक्टिविटी होती है वो लाइटली हायर होती है अनदर अप्लायंसेस की यहाँ पे बात की है, ओके। देन लास्ट है इलेक्ट्रिक पावर, द रेट एट विच इलेक्ट्रिक एनर्जी इज कंज्यूम्ड और डिसिपेटेड इन द इलेक्ट्रिक सर्किट। ये जो है इतना वो हम नेक्स्ट वीडियो में, नहीं ये इतना ही टॉपिक है, ओके। तो इलेक्ट्रिक पावर लास्ट टॉपिक है हमारा, P इज इक्वल टू वी इंटू आई, सो P इज इक्वल टू आई स्क्वायर आर इज इक्वल टू V2 अपॉन वी स्क्वायर अपॉन आर। सो ऐसा यूनिट ऑफ पावर इज इक्वल टू वॉट, देन 1 watt इज इक्वल टू 1 volt into 1 ampere. So commercial unit of electric energy is kilowatt hour. 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joule, and 1 kilowatt hour is equal to 1 unit of electric energy. Okay student, we completed the chapter number 12 electricity. Thank you.